good you beat what I mean.
Tangent. I'm trying to remember which one I did in class. You don't have a handout in front of you, did you?
I did.
I just don't want to do the same one. I want to do something different. What do we do?
In class we did
Tangent of. What did we do?
horizontal section shape. I don't have it.
Oh wait, it's not on the handout. It was in notes.
It's in my
It was
notes.
in notes.
Let me check my notes. In my notes, we have tangent, we did, we did y equals 3 tangent of x. That's not.
Tangent of 2x? Okay.
Yes.
So how about the tangent of 1/5 x?
There we go.
Okay, so when there's a number inside multiplying the x, what does it affect? What does it do?
The period.
Yeah, it's a horizontal stretch or shrink. In fact, this one is a stretch, but this affects the period. It changes the period to what?
We do this times. We don't do it divided by 2 pi this time, right?
It's the original period divided by b. Every time. It's the original period divided by b. And the original period, this time that was pi. With cosine it was 2 pi over b. Here it's pi over b. Okay? So that would be pi over 1/5, which
Why?
is 5 pi. That's the period.
Why is it pi over b again?
It's always the original period over that coefficient. And
Oh, that's right. Yeah.
okay.
So before the original period was 2 pi. That's why you did 2 pi over b. Yeah, I get that.
Okay, so the period is 5 pi. Now we don't choose the scale like we do for sine and cosine. We don't go, okay, so let's take the quarter period and so on. What I recommend you do on tangent is just find yourself an asymptote, even just one. And knowing the period and one asymptote, that'll dictate the rest of the graph. So how do we find the asymptotes? This is the part that students usually have a little trouble with.
Yeah.
You guys seemed to get it okay the other day, but let's see. Asymptotes always are when the denominator is 0. They will occur sometimes when the denominator is 0, but what?
When cosine equals 0, right?
Yeah, so this is, since tangent is sine over cosine, that will be when cosine of 1/5 x equals 0.
Pi over 2 and 3 pi over 2.
Cosine is 0 here and here when what's inside, the whole argument, when what's inside is pi over 2 and 3 pi over 2. So that would be when 1/5 x equals pi over 2 and 3 pi over 2, and there's infinitely many answers. I'm claiming if you were to just find one of them, you'd be fine. But that's not x, that's the argument, which is 1/5 x. How do I get x from there?
So, 0 equals.
How do I get x?
Times 1.
Multiply by 5. So x would have to be 5 pi over 2 and 15 pi over 2 and so on. Again, I'm claiming you really only need one. So when I go to graph this, (5 pi over 2), I could just make one unit be 5 pi over 2 if I wanted to. I think probably it's easier for most of us arithmetically if we just said, okay, I'll go with pi over 2. I'll make it kind of small though, because I got to go all the way out to 5 pi over 2 before something happens. So pi over 2, 2, 3, 4, this is 5 pi over 2. You could make each square be 5 pi over 2 if you wanted to. According to this, according to what I found here, I can see where the next asymptote is. But I can also use it this way. Because if the period is 5 pi, the next asymptote is going to occur 5 pi units down the road and 5 pi units backwards. Okay? So if I add 5 pi to 5 pi over 2, that's 15 pi over 2. So I got to go all the way out to 15. And I chose my scale really small, so that means I got to go pretty far out there. But most of you will have better luck arithmetically if you do it that way. All right, so what is that? 5 pi over 2, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15? So you get a pair of asymptotes. How do I find another one in the other direction?
You find a side in the next direction.
Just go 5 pi that way, right? Go 5 pi that way. So how do I go 5 pi that way?
Count 5 pi.
I can count 5 pi backwards. I can subtract 5 pi from there. Okay? 5 pi would be how many squares if I wanted to just count?
5.
Every square is pi over 2, so I need 5 pi. That would be 10 pi over 2. That would be 10 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That gives me negative 5 pi over 2. Okay, now if you know what the tangent does, really you've done all the hard work. Because once you find a pair of asymptotes, what can you say, what goes on in between?
This goes up and then
It's like
down.
it just goes up, kind of like x cubed.
Yeah.
Where does it cross the x-axis?
At the in between.
Halfway in between, right? So
half of
here,
a period.
half of that is at 0. Here, half of that would be, well, it's 10 squares across, so 5 squares in. 1, 2, 3, 4, 5. And so very roughly, what I'm concerned about really is that you have your zeros and your asymptotes in the right place.
I like this one way better than the side. You do?
You do?
Oh my gosh.
And if you wanted to get a feel for the vertical scale, halfway in between here and here is where the y value should be 1. So I'm not very picky about that, but I usually label where 1 unit is.
I like that a little better.
And what are the coordinates of this point right here?
10 pi over 2 and 0. Yeah.
Good. So it's 5 squares from there. So 5 pi over 2, 6, 7, 8, 9, 10 pi over 2. 10 pi over 2, comma 0. So 5 pi, comma 0?
Yeah.
So that would be a point that I would check. Put in 5 pi to here. You put in 5 pi to here. You have 1/5 times 5 pi is pi. And the tangent of pi is 0. What else? What's on your phone that